Welcome to the deep dive. Today, we are opening up the hood on modern software security. We're talking about something called static application security testing. You'll hear it called SAST. And our mission here is not just to define a bunch of acronyms, it's to give you a shortcut to understanding why security has to happen early and, how these automated tools can make secure coding the default, not some special exception. So to start, let's kind of set the stage here with this foundational concept. It's called the shift left philosophy. I mean, we've all been there, right? The deadline's coming, the code gets pushed out, and then the security team finally starts their big scan. If they find something critical at that stage, it's suddenly a huge panic.
Oh, absolutely. A multi-day fire drill.
Exactly, because historically security was this really expensive gate at the very end of the process. But with shift left, the idea is to move that security scanning from the end of a line right to the beginning. It has to happen inside your CI/CD pipeline.
And that why it matters part is.
Yeah.
It's just pure economics and risk management. I mean, think about it. Industry studies show that fixing a vulnerability late in the game, or worse, in production, it can cost, 30 to 100 times more than fixing it when you're first writing the code?
100 times, wow.
Yeah. So when you shift left, you're not just finding a bug. You're slashing the cost of poor quality. Security just becomes another part of quality control, like a unit test.
And that focus on prevention is really where SAST comes in, right?
Exactly where it lives. So let's actually drill into what SAST does, because it's a lot more than just, scanning for keywords. SAST stands for Static Application Security Testing. And the key detail is that it's static. It analyzes the source code itself without ever having to run the program.
So that's why it's called white box testing.
Precisely. White box means it has total transparency. You can see all the internal blueprints of the code.
So can you take us a layer deeper on that? What is the tool actually looking at? It's not just doing a text search for the word password, I assume.
No, absolutely not. The real power here is in its advanced analysis. So first, the scanner builds what's called an abstract syntax tree. It's basically a map of your code's structure.
Okay.
And then it uses these techniques like data flow analysis. It literally traces how data, especially from an untrusted user, flows through your application's logic. It's looking for those dangerous sinks where that data could cause a problem, like a malicious SQL query.
So it's finding things like configuration flaws, hard-coded secrets, stuff like that.
Exactly. And even potential injection vulnerabilities on code paths that might almost never get triggered during manual testing. It's a really exhaustive check.
That sounds incredibly thorough, but it makes me wonder, if SAST can do all that just from the source code, why do we need any other kind of testing?
That is a fantastic question, a really common one.
Doesn't the white box approach just make everything else redundant?
Not quite. And that brings us to the crucial distinction between SAST and its partner, which is DAST.
Dynamic Application Security Testing.
Correct. So while SAST is the white box looking at the source code, DAST is the black box.
So it's the opposite.
It's the opposite. Think of it this way. SAST finds the architectural weaknesses in your blueprint. DAST, on the other hand, it actually interacts with the running application.
Wow.
It has no idea what the code looks like inside. It just attacks the application from the outside, sending malicious requests and watching how it responds in real time.
So DAST finds runtime issues that SAST just can't see.
You got it.
Things like server misconfigurations or problems with authentication that only show up when the systems actually live.
Precisely. SAST is amazing for finding flaws in your code's logic, but it's blind to the environment it's running in. You need the black box of DAL to test the doors and windows of the deployed house, but you need the white box of SAST to make sure the foundation is solid before you even build it.
The earlier feedback loop, that makes sense.
It's the earliest possible feedback loop.
Okay, so that brings us to implementation. Because when a developer hears, we're running advanced static analysis on every single commit, the first thought is probably, oh, great, this is going to be complicated. Do you need a dedicated security engineer just to set this up, or is it simpler?
Well, it has to be simple. Operational simplicity is everything here. If it takes 3 days to configure a new security tool for a project, nobody's going to use it.
Right.
So the modern approach is all about automated templates. You don't build this from scratch. You just reference a pre-made blueprint.
So in the source material, we saw this often just means including a specific file in your configuration.
That's usually all it is. For example, you might just include a template file like job.st.gitlab-ci.iml right in your main CI/CD configuration.
And by doing that, what does that get you?
You instantly inherit a whole suite of optimized language-specific scanners. So if your project is Python, The system is smart enough to pull the right Python scanner and rules. If it's Go, it pulls the Go rules.
And all the setup and dependencies are just handled.
All handled behind the scenes.
See, that's the real aha moment for me. You don't need to be a security expert to deploy these expert tools.
You don't.
The automation handles the heavy lifting. But there's a challenge here. If Santer 6 is running this deep analysis on every commit, that can't be instant.
It's not. You're right.
So where does this actually run? And what's the impact on pipeline speed?
By default, SANT runs in the test stage of the CI/CD pipeline, and that's critical. It runs before anything gets built into an artifact or deployed.
Okay, so it's nice and early.
But you're right to be skeptical. It does add time. And this is the constant balancing act in DevSecOps. You accept a small increase in pipeline time, maybe a few extra minutes in that test stage, because that investment prevents a catastrophic failure later on that could cost you hours or days.
So we've defined the tool, we know it's easy to turn on, and it runs early in the test stage. The scan finishes, now what? Section 3, reporting and taking action. Because a scan that just spits out a 500-line log file is pretty much useless.
It is. You need actionable intelligence.
So where do the results actually land?
You need two views, the micro and the macro.
Okay.
So for the developer, the micro view, you need that feedback immediately. And it lands directly in the merge request widget.
Right there in their workflow.
Right there. When you push code that introduces a new vulnerability, you see a failing check with all the details right in the context of your change. That instant feedback is everything.
That's perfect for the person writing the code. But what about, say, an engineering manager or a security architect? They need to see the bigger picture across hundreds of projects.
And that's the macro view. That's what the security dashboard is for. This is where you escape what I call the tyranny of the spreadsheet.
Right.
The dashboard aggregates everything, SAST, DAST, dependency scanning across your whole organization.
Yeah.
So managers can see trends, prioritize risk, and actually prove that the security posture is getting better over time.
So you have the visibility, but now you have to act. And not every finding is a drop everything now kind of threat, right?
No, of course not. You'll have low severity issues, you'll have false positives.
Which brings us to triage. How do we manage that workflow?
Triage is the human judgment layer on top of the machine's findings. And we generally use 4 primary statuses to track a vulnerability's lifecycle. It always starts as detected. The scanner found something. That's it. It's just raw data.
Just a potential issue.
Right. Then a developer or security analyst looks at it. If they confirm it's a genuine exploitable flaw, it moves to confirmed. That's a commitment. Someone now owns the fix.
But what about those false positives or findings that aren't a real threat in your specific context?
That's where dismissed comes in. And there's some nuance here. You might dismiss something because it's a true false positive, or maybe it's an acceptable risk in some internal non-critical tool.
Okay.
Or, and this is important, it could be a real vulnerability that's already mitigated by something else, like a web application firewall. Dismissing it just cleans up the noise so the team can focus.
Right. Focus on what actually matters.
And then finally, the best status. Resolved. The developer pushes a fix, the system rescans the branch, and the vulnerability automatically moves to resolve. The loop is closed.
That whole system really does seem to transform security from, some annual checkbox activity into a daily part of the workflow.
It becomes part of the development muscle memory.
And you're making decisions based on clear, triaged data right in your merge request. You're not waiting 3 weeks for a ticket to show up from the security team.
You own the fix immediately.
Okay, let's wrap this deep dive up with the key takeaways. SAST and DAST is really the core tool for that shift-left philosophy. It's white box, it scans the source code itself, using some pretty sophisticated data flow analysis. It's enabled not by some complex setup, but by including simple shared templates. And crucially, it runs early in the test stage. This ensures issues are found and triage detected, confirmed, dismissed, or resolved, long before they become production nightmares.
And that efficiency, that abstraction of all the security complexity, brings me to a final thought for you to consider. Given that these automated templates do all the heavy lifting, running this analysis in the background, how does the adoption of a tool like SAST fundamentally change the job description of a developer? I mean, has the role shifted from just writing code that works, that might get checked by security later, to being inherently responsible for writing secure code every single time? Think about that shift in responsibility and how it empowers you as a developer to build better and safer software from the very first line of code.